Thank you for joining us today on the PowerMation YouTube channel. I'm Terry Busch, Business Development Manager for Logic, Controls, I/O, and Networking. Today we'll be... I see Terry Primary is having some troubles. Let me take over. Today we'll be talking about what high availability means to your business and what you can do to prevent unexpected costs to your organization. Thank you, Secondary Terry, but I'll take it from here. Okay, I guess I'm not needed here anymore. Gotta go. Today I'm joined by Rocco Fusco, another Business Development Manager at PowerMation. Rocco?
Thank you, Terry. Hi, my name is Rocco Fusco. I'm a Business Development Manager for Logic and Controls.
Before we can talk about high availability, we need to talk about downtime. We got to talk about unplanned downtime and the cost of that unplanned downtime. So the definition of downtime versus uptime. A lot of people in the industry talk about uptime as counting the nines. So 99% downtime versus 99.9 versus 99.99, and you're counting the nines. The best is 4 nines.
Downtime is the time when your machine is actually supposed to be producing parts. It's not scheduled downtime. It's not a shift that you're not running. This is a time when you're scheduled to run your production and you have unexpected downtime.
As an example, we could talk about the weekends, right? You plan on being down for the weekends, start back up again Monday morning. But if you go to start back up Monday morning, you hit the go button, the machines don't run, you've got a problem. Or if you've got a machine inside the facility that feeds all of the other machines, if it's plastic injection molding or some sort of chemical delivery system, and you've got an RO machine, you push the go button on the RO machine, you've got a whole bunch of workers standing around, the machine doesn't run, now the workers are sitting there doing nothing.
So you're saying we can have cascading effects where one machine goes down and it shuts down my entire facility?
The entire facility. So what we like to talk about is not just about the downtime in and of itself. We like to talk about the uptime, or otherwise known as availability. Let's compare two ventilation applications. One of them is a metro vehicle tunnel, where you've got cars driving under a city. The other is a poultry barn, where you've got turkeys, birds, and they both require ventilation.
So the ventilation in both these systems are considered life support systems, which are necessary to support, obviously, people getting trapped in the tunnel, or the life and health of the
of
turkeys.
A bird, of a turkey. So when you think about the cost of losing the bird or losing the person, those costs are different. You also have quality, you have production losses potentially, you can't bring the turkeys to market, but you also could have people losses. You could have carbon monoxide poisoning and things like that. So we have to design the systems to accommodate the ventilation, but we also have to have backup systems so that we don't lose people or lose birds.
So in some cases, a backup system may not be necessary because your costs are small. But if your costs are large, then the expense of a redundant system, just in having more availability to run your thing, just reduces your costs tremendously.
So backup system power might be important in a tunnel for people, maybe not so much for birds. Redundant networking, so that you have 2 paths of communications for your devices, maybe even something as simple as dual power supplies. And when you're building out a redundant system, when is too much? Too much? Too much cost? Too much infrastructure? Too much hardware? And when is enough not enough? So if you don't have enough to ventilate, maybe a system requires 10 fans and so you install 20, or maybe you install 5. So you have to understand what the balance of losses versus costs.
Yeah, so when we look at redundant hardware, we try to evaluate what the cost is compared to what the cost of the loss is.
Yep. So then we define what is really, when we're talking about high availability, what are we talking about? So high availability is more of a system cost. And what it can be is redundancy, just pure redundancy, replicating everything. So you have, like I said, twice as many fans going, twice as many controllers, twice as much real estate so that you have double everything. But that's not realistic.
Yeah. So it's not just control hardware being duplicated, it's also mechanical machinery being reproduced as well.
And the idea is that sometimes is called fault-tolerant systems. So you have exact replicated of everything. If one individual component in system A fails, 100% fail over to the other system, so 100% redundancy. That again isn't very viable because you're going to have a tremendous amount of cost replicating everything. You're basically building you're basically building one tunnel for the cost of two.
So in the past, a lot of these costs were very high. With today's technology, there's been some technology with media redundancy in rings. The cost of hardware has come down. So the cost of actually doing a redundant or a fault-tolerant system actually becomes quite cost-effective to be able to go after a whole lot of different processes that would cost too much money in the past.
And at the very end of that equation, what you're doing is you're planning for a disaster. So what if, right? So what if you lose all the fans in a barn? Your total loss to the birds is going to be the catastrophic cost. If you don't buy homeowners insurance and your house burns down, that's the cost of replacing your home that you have to think about. And so when we're looking at these individual systems, taking a holistic approach, we want to be able to say, hey, what's important, what's valuable? So the first would be in a system is like redundant communications to a process, right? So you've got an operator interface, you're watching the machine run. What happens if that operator interface is lost? Can the machine run by itself? Can that tunnel, can that barn cool the birds or give the people oxygen without an operator sitting there pushing the buttons? That's an important piece.
So you're saying if we do need an operator, maybe that's a situation where we need to have redundant communication networks or maybe even a redundant HMI.
And then you get down into the control level and say, well, what if we had a single controller, just one box controlling the whole process, but we're very vulnerable to outside, maybe lightning events, maybe people digging underground or something like that. Maybe it goes across parking lots. Maybe we need two methods of getting communications out to our I/O. Maybe this tunnel that we're talking about is 3 or 4 or 5 miles long. And so maybe we want different paths of communication. So that's where you get redundant on the I/O communications.
So actually being able to do two power feeds from two different directions, communication from two different directions. Maybe we set up a control system with power on one end of the tunnel, control system with controller and power on the other end of the tunnel, and now a collapser in the middle or on one end or the other gives us still control of that tunnel.
So at Powermation, one of our premium vendors is Emerson, and Emerson has done it right. Emerson has a system all the way from the HMI down to the I/O where you can replicate or have redundant systems in place. Again, you have to want to look at everything. You don't want to just say, well, let's make a duplicate of everything because it might be cost prohibitive, but you can duplicate individual pieces to make your system more high available, more nines at the end of the day. So first is I/O communications. That's pretty low cost. That's already built-in redundancy on the networking, so you just complete the wire.
Yeah, so we're talking about a redundant ring where it's self-healing. So
correct.
If we get a break in that cable, the communication will just wrap around in the other direction and everything will stay up and happy and keep running.
And the cost is a cable, and the cables are inexpensive.
Yeah. So an inexpensive add of a cable increases the availability of that system significantly.
Yep, because you could break a wire. Secondarily, a controller. Now, most people say, hey, what if that controller goes down? You should have one on the shelf. So now you take this controller, you purchase the controller, you stick it in a warehouse location someplace, and that becomes your backup. Well, as long as it's going to be sitting on premise, on your property, why not just install it in the control panel and have both controllers sitting there running all day long, and then if one of them fails, you move the cables over to the secondary one. Well, guess what? That's going to take time. And all the set points that were in controller number 1 need to be replicated into controller number 2. So even though you've got two controllers, that's what sometimes we call cold standby or a cold controller. So what we have the ability to do is take these two controllers, sit them side by side, and with a fiber optic link between them, we can synchronize the scans and we can synchronize all the I/O. So now both of these controllers are primed and ready to go. You've got a primary that's doing all the heavy lifting, and you've got a secondary coming in when the primary starts coughing, and the secondary takes over, controls the I/O, right?
Correct.
The secondary comes back on, or the secondary recognizes the primary came back online, primary takes back over again, and the secondary can gracefully walk away.
So in this case, we talk about redundancy, what's referred to as a warm standby, where you have a CPU that's there ready to go.
Yep.
It can be synchronized, but maybe not as a super high speed thing. We also have another solution that Emerson has that's extremely high availability, fault tolerant, and synchronized twice per scan. So the failover time of this high availability system is anywhere from 5 to 20 milliseconds. But if you can tolerate up to 300 milliseconds on a slower process, it's even less expensive because it's really the cost of a spare and a wire.
Yep. So in the terminology that we work with, we've got what we call I/O or a system that's hot standby. And what we mean by hot standby is you can bump. You can say, okay, run for a while. Maybe it's doing RO, maybe it's doing plastic for a plastic injection molding system. You're okay to have a half a second downtime while it switches over to the other controller. But there are situations where you need it to be scanned very, very quickly. If you're doing very time-sensitive things, you want the scans to be exactly synchronized. And that's why we have a system that's called bumpless. And bumpless standby is where both processors are running the exact same program at the exact same time, synchronize the data like Rocco said, so that if one fails, the other one instantly takes over, and now you're controlling your I/O.
So basically, if one CPU goes dead, we take over the same scan.
Correct, exactly. Now, what we didn't talk about today, which is a bit more complicated, is the I/O itself. And so the I/O can become very, very complicated and very expensive. So you could bring in your I/O into landing it to a single input card, and now you say, I need to double that. I don't trust my sensors. I want to have 2 sets of sensors. Maybe I want to have 3 sets, and I want to have a voting scheme. Those types of systems aren't really in the control space per se. Those are more in the actuation side of things and more in the detection side of things. But you can also add those in as well, and now you're doubling, tripling, or quadrupling your I/O, but we do have that system.
So if we went to what we referred to as a triple redundancy system and we had triplicated or duplicated I/O,
Yep.
now the system cost for getting high availability becomes very expensive.
Yep.
So now if your process is very critical and very expensive if it goes down, that's the type of system that you're willing to spend the money on because its cost of downtime is astronomical.
And so at one end of the spectrum, we have cold backups, things sitting on the shelf, system goes down, we can get it up and running in a little bit of time. Other end of the spectrum, we have double, triple, quadruple I/O points, multiple processors. The cost of that is astronomical. The cost of cold backup is the cost of doing business. And what we're saying is someplace in the middle is where every one of your applications can be, every one of your processes can be, and it's just a matter of determining the cost and adding a little bit of hardware to get your system available enough so that it can stay running when your people are standing around it. And so that's really what what high availability is all about, is making your systems highly available to your business and to be able to keep your business running. In conclusion, you want to be able to plan for a disaster and take the dollars when that disaster occurs, and then you can plan out your systems. And again, Emerson has high availability solutions that include redundancy where you need it, and it's very, very cost effective.
That's the end of it.
I don't know. Is it the end? Is it the end? The thank you kind of a thing, or?
Is this going to be in the video?
I don't know. Do we want to have a thank you, or does that seem kind of silly?
Should we just say thank you and thanks for watching the Power Mission YouTube channel?
Thanks for joining us.
I think that's all right, and we can cut it there.
Thanks for watching the Power Mission YouTube channel.
So what about 3 Roccos? Is anybody interested in that? I think that's a really good idea, Rocco.